then take this and just put it right here in the center of your chest.
Okay.
Flip it right there. Yeah, that's good. There you go. And then just as soon as that displays on the thing, you'll be good to go. Be Gucci, man. Looks good to me, man.
All right. So hello, everyone.
Very sorry.
Today I am presenting on how I accidentally discovered CVE-2017-1000382. This is a security vulnerability in Vim that allows for a couple interesting things. First, who am I? For those of you who don't know, I'm a junior here in the CSEC department. I created and maintain Cucumber Linux, and I really love all things Unix. As you can see, my favorite programming language is C, favorite scripting language is Bash, so I'm very much a Unix person. So, how did this all begin? Began November 2nd, 2017. I set out that morning to analyze a vulnerability on Cucumber Linux that had just come through in Vim. It was slightly different, but it was very closely related to what I ultimately discovered. So, I wasn't looking to discover a CVE at that time. I had no idea I was going to discover a CVE, but anyway, I was just analyzing this vulnerability. It was discovered by Hanno Buck of the Fuzzing project. I don't know if any of you are familiar with him. He does a lot of really great work and a lot of really cutting-edge Linux vulnerability research. But yes, so this vulnerability, it allowed a remote attacker to obtain the database credentials for a WordPress database from a WordPress site, amongst other things. So how did this vulnerability work, you might ask? It exploits the way Vim handles its .swap files. So as I'm sure anyone who's ever used Vim knows, Vim, it creates a swap file whenever you edit a file. This file contains recovery information, so that in case your Vim session crashes, you can recover what you were editing next time you go to edit that file. It also, this is a little less known, contains the entire contents of the file you're editing. So yeah, it sticks around until Vim exits properly, at which point the swap file is deleted. And we have this lovely text here. I'm sure all of you have seen that at some point. If you haven't, you will be. So how does this relate to WordPress? So all of our database credentials in WordPress are stored in our lovely wp-config.php file. Now, this is in the public HTML directory, which is what gets served up to the internet when people connect to the site. But it's a .php script, and anything you put inside of a PHP tag in a PHP script, it gets parsed by the PHP preprocessor, and it doesn't ultimately get sent to the client. So we should be fine. It's secure, right? Well, turns out not, because let's say now the system administrator goes to edit that file in Vim. What's going to happen? It's going to create our lovely swap file right in that directory. But that swap file is not a .php file, it is a .swp file. The PHP preprocessor only parses files that end in .php. So this file is not going to get parsed. So what happens? Now if you just go to your website /wp-config.php.swap, you can get the contents of that file and get the site's database credentials. And this requires someone to be actively editing the wp-config file, which happens from time to time. Big concern here is if the system administrator's Vim session crashes while he's editing the file, that swap file is going to stick around for a really long time until a system administrator goes to edit that file again and specifically deletes the file, or until he realizes there's an extra swap file lying around and deletes it manually. So we're going to have our first proof of concept here. So you'll see I have my lovely, super secure WordPress site here. It's so secure, no one could ever break into it. See, I even bought the domain name example.com. No one will bother trying to hack that, right? Because everyone thinks, oh, that's just the example website you use for like documentation. No one actually runs anything on example.com. Little do they know it was available, so I bought it. No, I'm just memeing. I didn't actually buy it. You can't do that. Anywho, so we have our webmaster here. We are in our serve www.html directory. It's basically the same thing as var www HTML. Cucumber Linux just does things a little differently with the file system hierarchy. But it works the same exact way. This is where all of our HTML files are. So you see, we have our lovely wp-config.php file right here. So now let's go ahead, whoops, and edit that file. So now we have our session open. And now, if we go to example.com/.wp-config.php.swap, it will now give us the option to save that file. So we can go ahead and save it. Now let me go and open that up. And here we go. It looks a little odd. But if we search for, let's say, password, we have right there is our WordPress database password, along with all of the other WordPress database credentials. So yeah, you know, I hope when you set up the permissions for a CVE somewhere you could only log in from like the one specific host that WordPress is running on. Otherwise, this might be an issue. So at this point, you're probably thinking, well, this is all very theoretical, but like no one would actually be dumb enough to do this in the real world. Well, that is not true. Hanno Bock, when he discovered this vulnerability, he went and he scanned a bunch of the top WordPress sites. And he found 25 of them were vulnerable to this. So he quickly contacted the webmasters. They were very quick to remove those swap files. And then he reported the vulnerability. So now, I was analyzing this vulnerability. So it was given this description in MITRE CVE dictionary. So Vim, that version, ignores the UMask when creating a swap file. So it occurred to me that that description has, one, nothing to do with the issue we just encountered with WordPress. Because like the original file, it was readable by the web server. So that means even if the swap file had the same exact permissions, it would be readable by the web server. So regardless of whether or not that was the case, that didn't have anything to do with that vulnerability. I found out that wasn't the case. Like Vim, it had nothing to do with the UMask, how it set the permissions for swap files. Yeah, it seemed like the UMask should be ignored, and that would make more sense to copy the permissions of the original file, which supposedly was the behavior Vim had. Supposedly. Anyway, I was investigating this vulnerability further, so I decided to run an ls-la on my public HTML directory to see what was going on for myself, and this is what I got. So now, does anyone notice anything alarming about that? Yeah, Joe.
The user permissions are different between the two files.
Yes, exactly, and this should terrify all of you. Because the original file, it was owned by Apache, the group was Apache. So Webmaster, he's a member of the Apache group, so he can edit the file just fine, because it's chmod to 660. However, the primary group for Webmaster is not Apache, it is users. So, turns out Vim, when it creates your swap file, it does copy the permissions from the original file, more or less. However, it does not chgroup the file to the group ownership of the original file. Now, it tries to do this, but on Linux, you cannot chgroup a file unless you're root. So unless you're root, and even if you're root, there are still a couple other conditions that have to be met. And unless these very specific conditions are met, that's going to fail, and you're just going to end up with a swap file that's readable by the user's default group. So now, in addition to exposing all of our WordPress credentials remotely, we're now also exposing them locally. So at first, I wasn't sure if this was really a distinct vulnerability from Hanno Bock's vulnerability. It seemed very similar in the way it worked. So I was like, is this really something different, or is it just an extension of his vulnerability that I didn't think for? So I phoned one of my technical friends, and we spoke about it for a while. And ultimately, we both agreed that it was possible to fix one vulnerability without fixing the other. I could set the permissions to be correct on the swap file and still have it be visible on the web server. So given that, we both ultimately agreed that this was, in fact, a separate vulnerability. So I discovered a vulnerability, and now what? I'd never done this before. I wasn't quite sure how to proceed. I'd analyzed a lot of other people's vulnerabilities. I'd read a lot of other vulnerability reports. And I knew like there's a lot of stuff that people often didn't include in their reports. I knew there were a lot of bad things people did when they reported a vulnerability. So I wasn't quite sure how to go about reporting it, but I knew a bunch of things I definitely did not want to do. So big issue I had was how should I disclose it? Do I want to disclose it immediately or try to come up with a fix? Should I do a full disclosure or a coordinated disclosure? But fortunately, I came up with a fix for both of these vulnerabilities very quickly. And what that was each user got a dedicated directory to store his Vim swap files under ~/.vim/swap. This directory was chmod to 700, so only that user could access the contents of that directory. And then Vim was reconfigured to store the swap files in that directory on a per user basis. So now, proof of concept number 2. So we have here 2 users. We have our root user right here, and then our somewhat privileged user right here. Now, I could exploit this vulnerability on our WordPress config file, but I just did that, and we can do better than that. But whenever I come up with these proof of concepts, I always like to choose very dramatic examples. It's a lot more interesting if you just choose like some random file somewhere that no one cares about. So we're going to take a look at Etsy Shadow. So let's say our root user happens to edit Etsy Shadow. Before we do that, let's just do a click ls-la/etsy and then grep for shadow. So you see we have these 4 files there. The original shadow file, it's read-write by root, read-only by shadow. So now the somewhat privileged user, he is a member of the users group and the root group. Because he's somewhat privileged, he needs access to some administrator stuff. But he's not a member of the shadow group, and he's not root. So if he goes to cat Etsy shadow, that's not going to work. Now root goes to edit that file, though. And if we go ahead and do this again, we now have our swap file. And the group ownership is root, which this user is a member of. So now he can just go and do cat etsy.shadow.swap. And there we go. There's all of your password hashes. So I hope it's going to take a while to break these hashes. Or, oh, wait a minute, that's right, it's Linux. So we're using SHA-512 to hash passwords. So it's not going to take very long at all. Whoops. So yeah, that had happened. So now it's time to disclose. So I had my fix ready. Or, oh, one more thing I wanted to say with the proof of concept was, right, the actual fix. So Vim, it stores its global configuration file in Etsy vimrc on most distributions. And you see right here I have the patch commented out. So we're just going to uncomment that. And yeah, it just says create our swap directory if it doesn't already exist. Make sure it's mode 700. And then set the swap file directory to that directory. So now we can confirm that the swap file is no longer there. Now root goes to edit Etsy shadow again. Only this time the swap file is no longer there. So if we go and we look, we can actually see that we have a .vim directory here in our root's home directory now. And then we have the swap file directory. And now that is, in fact, our swap file there. And this directory is accessible only by root. So problem solved, right? So I opted to disclose right away, given that the Vim developers, they already didn't care about the first vulnerability. They didn't want to fix that. So I thought, OK, well, if they don't really want to fix that vulnerability, which is arguably worse than what I discovered, then they're probably not going to want to fix this either. So there's probably not a whole lot to be gained from doing a coordinated disclosure here. Plus, I have a fix ready, so I'm just going to full disclose right away. So I did that. I posted a disclosure on the Vim development mailing list, and then I CC'd OSS security as well. And then I requested a CVE ID and got provided CVE-2017-1000382 by MITRE. So now, the response from Bram Moolenaar, the lovely, not-so-benevolent dictator for life of Vim. Yeah, he didn't view this as a problem. He had a couple of great quotes here, and if you don't believe me, this is all publicly available on the Vim mailing list, so you can go read it for yourself. He said, "Why would a web server expose and serve such a file? That's clearly the problem there. It's nothing to do with the fact that Vim creates its swap files there." And he further said, you know, system administrators, they should be aware that a swap file is going to get created and be accessible to everyone every time they go to edit a file in Vim anyway. So they should know how to protect against this on their own. They should be aware of it. I was like, really? This vulnerability's been around for, I went and looked through the Vim source code. It's like, no joke, over 25 years it's been around. And nobody noticed it until now. So I think it's pretty safe to say people aren't really paying too much attention to that. But either way, he didn't want to fix that. So after I disclosed my vulnerability, Bram didn't view that as a problem either. It's like, oh yeah, if the user's primary group is a group that every member of the system, every user on the system is a member of already, then that's really just asking for trouble. So that's also really more on the system administrator, not on Vim. It's not a Vim problem. So fortunately, there's enough public backlash from myself and several other developers on the mailing list that he ultimately had to backpedal that a little bit and agree to do something about it. So we have the quote-unquote solution here. So Bram, this guy right here, he didn't really care for my solution at all. He had a few reasons he didn't care. Most of them are completely bogus, such as this allowed the user to detect if another user was already editing the file because you'd get the swap file warning. Oh, the swap file already exists. And OK, that's not a reliable way to tell that for a couple of reasons. One, it could be that the session just crashed and the swap file's still there and no one's actually editing the file right now. And also, what if that other user who's editing the file doesn't like Vim? What if he's one of the Emacs people and he uses Emacs? Then that file's not going to get created, so that's not going to work anyway. So there's just too many variables in that case for that to be a reliable way of determining whether the file's already being edited or not. So bogus. And this allowed a user to recover another user's session if it crashed. So let's say I am editing a file and my Vim session crashes. And then Joe here decides he wants to edit that same file. And for some reason he decides, you know what, Scott, he was in the middle of editing this file and he didn't save it properly. So I better recover his changes, see what he was doing when his session crashed. He could recover my file.
I'm just trying to help you out. You launch content.
Yeah, but it's like, do I necessarily want every user who has access to that file being able to recover not even the changes I wrote, just my draft changes that were there when it crashed? Not so sure about that. And just, I don't know, to me it seems like giving users access to other users' session data in Vim just is not a good idea and is probably going to lead to other security problems down the road. So that was also bogus in my mind. The one legitimate point was if the file was on an external device and that device was disconnected while the Vim session was open, and then that device was plugged into another computer, the user on that other computer, if he was also using Vim, he could recover that file. So yes, that is one legitimate use case that we'd lose with my solution. But it's like there's always a trade-off to be made between usability and security. I personally really think that's much more of an edge case. I don't think that's something most people are generally going to have a huge issue with. Plus, I feel like if you have an external device mounted on a Linux system and you just yank the device out without unmounting it first and data gets corrupted, I feel like that's kind of on you at that point. Just my opinion, though. So anyway, he instead decided, oh, you know what? We're just going to chmod the swap file so that the group permission bits get set to the same thing as the other permission bits. So that way, whatever group happens to be at user's primary group won't get any more access than other users had in the first place. Now, I, of course, replied and said, this is a horrible idea for 2 reasons. One, it doesn't fix this other vulnerability here. And that's a very big problem. But he didn't think that was actually an issue with Vim, so he didn't care about that. Also, group blacklisting. Are any of you familiar with group blacklisting on Unix systems? No. OK, well then what that is if, say, you want to have a file, and you want everyone on the system to be able to read the file, except for maybe one group of users, we'll call them like the bad boys. They did something bad, so they don't get access to this file that everyone else has access to now. What you can do is you can chgroup the file to bad boys, and then set the file permissions to like 604. So the owner still has read-write access. Everyone has read access to it except for the bad boys group doesn't have any access to it. Since group access takes precedence over read access, that effectively blacklists the bad boys group from being able to read that file while allowing everyone else to read that file. Now, in this case, when you go to edit that file, the swap file, it's going to get created with the permissions 644 chgrouped to some arbitrary group. So that defeated the group blacklisting. Now that blacklisted group can again access that file. So I was not at all happy with this solution. A bunch of other people weren't. But hey, Bram is a benevolent dictator for life, so he gets to do whatever he wants. And we're all basically stuck living with it. So the status now. My vulnerability, CVE-2017-1000382, it was fixed upstream in Vim 8.0.1263 using Bram's solution. Now, on Cucumber Linux, I decided to go my own way, and I employed my solution specifically, which is why you saw those lines were in our vimrc earlier. That's standard on all Cucumber Linux systems. And this patch, though, was not backported to any major distributions. So all the stable distributions that haven't already updated to that new version of Vim, like, say, Red Hat, Debian, Slackware, they're all still vulnerable to this. And HANA's vulnerability, CVE-2017-1000382, that was never actually fixed upstream. And therefore, every Linux distribution currently in existence is vulnerable to it, except for Cucumber Linux, because I employed my fix there, which also fixes that vulnerability. But you know what the old developers say, the good old saying, there are no bugs, only undocumented features. So we can safely cast this issue aside now, and it's taken care of. We don't need to think about it anymore. So what did I learn? First off, Bram Moolenaar is basically a jerk. He is not pleasant to work with, and he's very difficult. This is a sentiment shared by many in the open source community. You can go and read online. There are a bunch of mailing lists where people have complained about how much they hate working with Bram Moolenaar. And he doesn't seem to care about security either. So also, I learned that apparently a group of people many years ago got so annoyed with Bram Moolenaar that they decided to fork Vim and create NeoVim and go do their own thing instead. NeoVim, it just so happens they decided to take my solution. They incorporated that many years ago as just a general improvement. They thought it was a better way to do things. So NeoVim had fixed both of these vulnerabilities for years before we ever discovered them. It also supports a lot of other cool features that standard Vim does not. Like in NeoVim, you can write plugins in Lua instead of Vim script. It also supports threading, so you can have multiple cursors if you want to, and it has a lot of other cool features. So in other words, NeoVim, in my opinion, is all around better than Vim. And the next version of Cucumber Linux, we will be replacing Vim with NeoVim. And also, this week, on about Wednesday, I learned that if you ever discover a CVE and you put that on your resume, every employer you ever talk to will want to hear the full story about it and all of the gory details. So you better make sure you have a good story to tell. So here are some links for further reading if anyone's interested. This presentation will be posted in Workplace and on my website. So any questions? Anyone? Nope? OK.